Why sinter quality drives blast furnace efficiency? So let's begin with the foundation. Sinter contribute up to 80% of blast furnace burden. Its quality is not just important, it's decisive. High Fe content in sinter led to lower coke consumption and better furnace permeability. Even a 1% rise in Fe can cut coke rate by 2 kg per ton hot metal, which is a itself big quantity. If you want consistent productivity and lower cost, this is where the battle begins. Now, coming to the optimization granulation with IMGS technology, that is next granulation, it is too often underestimated. The IMGS system revolutionizes how we prepare our sinter mix. Uniform granulation enhances bed permeability, reduces fines, and boosts sinter strength up by 5%. Moisture control is sharper and yield more predictable. This is not just technology, it's a basically transformation. IMGS technology there are a four core impact on a sinter granulation, and one by one we will follow it. First is the superior raw mix homogeneity. IMGS uses a high speed intensive mixture to thoroughly blend coarse, fine and ultra fine ores, additive and recycled material. This results in uniform distribution of all particles and solid fuel, even when using up to 80% pellet feed, and they are in particularly less than 0.1 mm, supporting high quality sinter formation. Second is enhanced granule size control and reduce fines. Intensive mixing and controlled granulation yield a narrower, more desirable granule size distribution, maximizing 1040 mm sinter and minimizing fines less than 5 mm. A stronger, well formed granules withstand transfer and layering, reducing breakage and dust, essential for optimum blast furnace permeability and efficiency. Higher productivity and process stability. Uniform granulated mix improves bed permeability, promote even gas flow and support higher vertical sintering speeds. That is 10 to 12% increase in reported. Enhances strength and consistency of green balls, lead to more stable sintering and higher overall sinter yield and mechanical quality. Greater raw material flexibility and efficiency. The system enables increased use of fine and recycled material without compromising sinter quality. Estimate need for large pre-blending yards. Bunker blending alone suffices, reducing capital and operating cost and improving environmental sustainability. Now, coming to our next slide, which is regarding a chemical composition, the balancing act we have to check into with respect to chemical composition. As we can see that, so we can say that let us talk on chemistry and focus on chemistry. Basicity matters, and it is like that if we are aiming something CO by SiO2 around 1.8 to 2.0, and we have to keep MgO around 2.5%. It's a delicate balance, yet we must have to get it right, so that there will be a drop in slag volume, hot metal purity also rises, and furnace stability improves. So use of also premium limestone and dolomite to control flux input. It's a precision chemistry for powerful result. is also very much driven by such type of limestone and dolomite. Now coming to the segregated blend loading for uniform sintering, we can say that moving on to blend loading is a very important activity. By layering raw mix based on particle size and chemistry, we unlock uniform sintering. This reduces the return fines and enhance productivity up to 6% in some plant. It's a smart, simple and proven. Think of it as a tailoring your feedstock for optimal heat transfer and sinter consolidation.